All right, welcome back. So today we're going to be doing a tutorial on converting the micro servos to have an analog output that you can read. The micro servos I find to be the most difficult of all the servos to convert. So if you haven't watched already, it's probably maybe a good idea to watch the other just general larger servo tutorial on sort of the background on the servos and just generally how they work and what's inside of them. But we're going to look today at the specifics for the micro servo. The biggest reason these are a problem is because of the limited space that we have inside here to work with. There's not a lot of spare room in here to run these extra wires. And it's also, there's not quite the same sort of signal that's easy to get to. So we're going to get started though. So the biggest challenge with these micro servos is getting the screws out. They're very small, they're very easy to strip. I found the key is to have a really good screwdriver. Make sure you have the right screwdriver for the job. For the micro servos, I kind of like this servo right here. These are about maybe $7 or $8. If you're doing more than one, it's probably a good idea. So you should use a Phillips triple lot screwdriver. So yeah, this one's pretty good. Seems to work pretty well. And then just like the other servo, we just start by taking off these screws. Really making sure we don't ever slip. You slip even once on these screws and that can strip them and they're junk. So these servos cost about $3 and it really tells it really shows when you're working with them. So very soft steel on these screws and they're just tiny. Okay, and these servos are held together a little bit with stickers as well. So just like the other servos, they're sort of three pieces. There's sort of two ends and then sort of a center shell here. But in this case, the sticker on here is kind of holding it in place. So one thing we have to do that we didn't have to do with the other one is just take a knife, and we could peel back the sticker, I suppose, but I'm just going to cut it. Do a bad job of cutting it. That was very, very bad job of cutting it. Okay, well that should be good enough. Okay, so we're just trying to break that sticker so that this thing can come off. So now it pops off pretty easily after those stickers are removed. And just taking these screws out. Okay, put that off to the side. So just like in the other servo, we have a very similar thing. We have the electronics board here, and then we have our motor, and then we have underneath it we have the potentiometer. So we also have in this particular device, we have a little piece of plastic in here. You can kind of see it if you look in there. A little piece of plastic. That little piece of plastic, it just protects the electronics after this gets sandwiched in. So it's protecting that from that potentiometer, those potentiometer connections from this circuit here. So although it is handy just to double check our work, we want to look at the center tap. If you look at that potentiometer, you can see three little prongs in there, and it's the middle prong on there that's our center tap of that pot. And I always like to just double check and follow those leads back and make sure it is in fact the lead we're trying to get to. So in this case, the lead we're trying to solder onto is this second one. So again, I don't know. Yeah. So again, we have I'll use the screwdriver here. We have 1, 2, 3 solder connections for these wires. We're connecting to the middle one. And the problem we have here is we need to solder a wire on here, but the wires come out on this side, on the other side of the board. And in this case, they're not through hole. So, I mean, the solder connection doesn't go all the way through as it did with the bigger servos. So one of the issues that we're going to have with this is we have to connect a wire, but then that wire has to get around to the other side of the board and still have room in here, and there's not a lot of room to work with. So it's just something we have to deal with. There's no real good solution to it. But like with everything else, just make sure there's plenty of, make sure you leave yourself enough wire when you make this connection. Make sure there's enough space for it. So, okay, so what I'm going to do is I'm going to cut a length of wire now to make the signal connection. And it's a good idea to be consistent with whatever. Oh, look at that. Somebody took my wire. That's the solid core. So I really don't like solid core for this, mostly because if you go with solid core, you don't have enough. It tends to not be flexible enough, and especially for these little servos, you need to have a flexible wire. We probably should be going with a thinner wire than I've got here. It's just, this is sort of just what I have. I'm going to follow the same process of just stripping off a tiny little bit from the end here. Then I'm going to flux the end of this. The reason I only strip off a tiny little bit is we really don't want to have extra, we don't have extra wire dangling around here. We don't have extra, you know, a lot of extra unshielded wire inside this servo. So what I'm going to do now is I'm going to solder this wire to that middle connection. So the wire is going to be soldered right here to this middle connector. And I think for this time, I'm just going to run it over all the way across the board and then bring it back through this corner once we eventually bring it out. But so that's going to be my technique. I haven't tried that before, but there's some little gaps on the side of this motor here. See, this motor is not rectangular. So there's some little gaps just right here that I think I can get that wire to go through. Oops, got a little flux on there. Okay. All right, well, so let's just get started soldering here. So as before, I'm just gonna get a little bit of solder on the tip of this wire. This is not proper soldering technique here. This is definitely not the safe way to do it. And my iron is cold. Why is my iron cold? Oh my. My iron's cold because I had the wrong iron turned on. So now that we got the right iron on, again, that's not the way you're supposed to do it. You're not supposed to put solder directly on the tip, but you know, sometimes the rules are meant to be broken. Okay, so I'm just going to solder that on here. The main thing is, and actually I want to be careful because when I soldered that, I think I made a little too much space. So I might even trim just a little bit more of that wire off. Sometimes when you solder when you kind of pre-tin a wire like this, sometimes that heat kind of pulls back the insulation on the wire. So when it pulled that insulation back, it kind of exposed a little more than I wanted exposed. So I think I'm good now. So I'm going to line this up, bend it kind of in the shape I want it to be, line this up, and solder it on. And after I solder it on, I really want to make sure that I don't have any bridges. I want to make sure that it is soldered to what I want it to be soldered to, and that it's not connected to things I don't want it connected to. And actually right now it's a little too close for comfort for me to this capacitor we have on here. So I'm going to just give it a little extra heat, move it a little bit. I'm going to give it a little bit of heat. Still too close for comfort for me. Okay, so I ended up just taking it off. And maybe what I'll do is I'm kind of trying to keep it in the video while doing this soldering, and I should have an extra set of hands here. Yeah, maybe we'll just go totally sideways here. I can't really keep it in the video up close, so I'll just move it off to the side here. Alright, hopefully you fast forwarded through this in the video. I could edit it out, but I don't want to. Oh, now I totally disconnected that wire. That's fun. Alright, sometimes these things happen. Totally disconnected that wire. Well, let's make some lemonade here. The two wires are soldered to each other now. And now they're soldered to that connection on the board. Okay. So, didn't want to do that. Ended up, I meant to route it the other way, but as fate would have it, we're not going to do that. So we're going to route it this way. Okay, so
I verified that we have all the components that we need, so do you think I should just paste it up and get rolling on that? Yeah. Okay, cool. Sorry for interrupting.
No, it's all right. So I think all those connections look good, just double checking. Now I'm gonna, like previously, we're gonna have to make space for this thing. So to make space for this, we have this connector here. We have our housing. It's got that little notch there. We're gonna have to widen that notch out a little bit here. So we're gonna have to, I just take little nibblers and nibble a little extra space here. Maybe nibble a little bit more. Maybe take an X-Acto. Okay, so now we should have enough space in that to wedge this thing in. So now the tough thing is always getting this thing back out of the container here. So so to shove it back in, we got to kind of get a little fancy here. So I'm going to bend this wire down a little bit, and then maybe out. This is where having flexible wires really helps too, so which we don't really have. So we gotta kind of stuff this guy back in there. This is also where having used a thinner wire would have really been nice. It's kind of a strategic error on my part. So wedge that in there. That might be good enough right now. I don't know. We got to check sort of the housing clearance here, but this might be sandwiched in there good enough. All right. Well, let's check it and see if that's in there good enough. Yeah, I think it's going to work. So we just gotta stuff these back in. I'm kind of getting tired of these little screws here. So it looks like we actually don't have enough space right now in the plastic for this thing, so I'm going to carve out a little more, or nibble out a little bit more space in this. Really, I should have used a thinner wire to begin with here. This was way too thick of a wire to start with. This is just a signal wire, so it doesn't need to be huge. It doesn't need to carry a lot of current. It's just carrying an analog signal, so there was no need for it to be this big. It was just the wire that I had laying around, so. Okay, let's try to get this back into its housing. I think that's pretty good. Okay, I think that's pretty good. So we'll keep it there. Start to put a little screw in this thing and see what ends up happening. Yep, it's getting pinched, but I think it's okay. Now don't over tighten these two because again it's very delicate. And also just to remind again, make sure to use the right screwdriver. Okay, alright. Looks pretty good. We got the servo connection coming out. I'll call this a win. Hopefully. We got to test it to make sure it works, make sure we can actually see that analog signal, but I'm feeling pretty good about it. So. Alrighty, well, thanks for watching. Smash that like button or whatever they say.